Hey, my name is Subu Balakrishnan. I work at Aeris Communication. So today, I'm trying to walk through, typical components associated with IoT and how stream processing relates to it, and some of the experiences that I've been having with Aeris, and Aeris as a company, the journey we have been going through it. I want to kind of expose you guys to that. And it's a 30-minute, so normally I tend to do these things over a longer period. This is a 30-minute session. So there may be some, we have to kind of have some wiggle room, we can play around with it. You can reach me in that email address. So the topic, like I mentioned, we're going to be talking about what is IoT. So I can spend more time, less time, depending on the level of people familiarity with the IoT. So in a show of hands, can I get an idea about how many people know what IoT, have been working on the IoT for some time? Okay. So I see around 1/3 of the people here, they are familiar with IoT, looks like they have been working on it. So I will try to keep my flow along those. And generally, I use, the O'Reilly blog, stream processing idioms. We'll go through what the idiom is, and I can show of hands how many people have been kind of working on production systems and stream processing in this. Okay, it seems to be around 30% there again. So again, if you're already familiar with it, that you probably know what I'm talking about. We'll go through that, and then we'll talk about the data processing aspects of the IoT. What is a typical IoT application? What are data processing elements? And we'll try to marry up, and then I'll try to focus on these three areas of the IoT, because overall IoT data processing, just like any other application, has stream processing elements to it, right? I'm not going to be focusing on that. I'm going to be focusing on the aspects related to IoT device types, the connectivity type, and network protocol type. So these are some of the things that you need to be aware of. Think about those, apply those IoT aspects to a stream processing idiom. So we'll try to look at that together. So a brief introduction. Again, this photo probably is taken in 2017 California with all the rains. You see all the greens there. So Aeris actually has been in the IoT space. It used to be called as M2M. 10 years back. We have been in the space for the last 10 years, and we generally focus on multiple aspects of taking unconnected devices to a connected device and providing value to the business and providing value to social cause. You'll also hear some social cause aspect here. So again, the way you can see the references for things up there, so you can look it up, reference in the slide later. The way I think about that is, it's again another one of the iteration, right? We always go through another technology iteration where, hey, is that really possible, right? So this IoT is one such iteration, and they also see there's another iteration of democratization of technology, right? So if you think about the basic mobile app, the SMS concept reached out to villages in the worldwide. It democratized the technology that allowed innovation, and people's changes, their day-to-day life changed dramatically with that. So I see the IoT is another iteration of that. People generally map that out to, the things, variables like this, or more advanced industrial, monitoring and things like that. So you have to realize that you have to. I don't know how many people remember this. If you actually ever driving a car with the old tape player, and you got one of the newer CD, you got an actual CD player, then you use adapter like this, right? So IoT is going to go through that phase for next 10 years, right? So there's a lot of investment in big cars and machines, and they're not going to be reinventing that. So to make a change, just to give an idea, if you're working with a car manufacturer, to make a change in a car, you have to plan 2-3 years ahead of time. Just for the design freeze, and the car that you're driving this year, probably a design freeze happened 3-4 years back. So which means you have to start the process 4-5 years back. So you have to realize that a lot of investment is already there. Those machines are not going to be changed. So you're going to go through the phase of slapping on the adapters in the IoT. So how it translates to stream processing, you will see things like that, along the way. So if you think about, it is not only about those, commercial stuff you talk about. It actually can make a social impact in the world, right? So if you take the example, around 800,000 child die annually according to these studies, based on the pollution level and the air quality caused by using fossil fuel for cooking. That is, unclean fossil fuel, I should say, right? Because the liquid LPG or liquid petroleum gasoline, those tanks actually, they can't afford that. Most people, if you remember, if you think about somebody who can, many times these people actually make day-to-day living, right? So they don't even necessarily cook every day. So what they do is they actually cook good food probably 2-3 times a week, probably even once a week, right? So in that case, for them actually, how would they afford to even have an LPG tank in the stove? So there are organizations which are working towards having pay-as-you-go model, which allows them to have a connected IoT-enabled LPG tank, which allows them to pay maybe 2 or 3 times the use. So the companies are investing in that, and that makes a big difference in their life. So if you think about another example like this, where there's another example of democratization of technology in IoT. So if you look at this distribution of the typical farm size across different parts of the world, right? So Asia and Africa, you can see the farm size is smaller. So how do you make a difference to a farmer's life, of many things? You basically want to have a tractor, you want to have equipment. If you have a small farm, you can't really afford to have an equipment, right? So how do you manage that part? So that actually, again, in IoT-enabled, a bunch of companies, what they do is they find people who are decent money. They think about this investment. So they buy an IoT-enabled connected tractor. The tractor actually, people use their SMS to ask for that. So if you think about this as logical Uber for tractors for farmers, right? So they are actually using it essentially maybe 20 hours a year, actually. So they don't know exactly when they need it. So the problem gets slightly more complex. If you think about the way the agriculture thing works, in developing countries, many of them don't have, if you think about how it works here you have, nowadays we have fully filled lakes, but even if you don't have that, you have pumps, you are able to get groundwater. So you manage the water supply to some extent. If you think about developing countries, many of them actually literally the way they run the farming is through waiting for the rain. So the tractor availability itself has to be a function of what is the weather, where it rains. So if you think about in a stream processing point of view, how we can marry the weather data from stream requirement data for the connected tractor, then you are able to optimize the way to actually make the tractor available in the right place in the right time, right? So these are examples of where I feel the IoT is not, we focus a lot about the consumer apps, we focus a lot about connected cars. This is an area where large population countries like India and China and many of the African countries, the IoT can make a big difference in terms of their day-to-day life. So from a stream processing point of view, the way I see that is the IoT devices are designed to actually work in the rain, low temperature, high temperature, in a very rugged manner most of the time, right? Depends on the cost of the device, type of the device. So the devices are always ready to send the data. So nowadays, the cellular cost is coming down. And because the cellular cost is coming down, the IoT device at most of the time is up and running, is ready to send the data. So you need a stream processing platform that lives up to it, right? It has to actually respond to the system on time. So that is where the IoT really pushes the stream processing in many ways. So where I see that is, if you think about big data actually was pushed a lot by the social apps and the search tools. I feel the IoT is going to be one of the main drivers behind stream processing because it requires the context, it requires the problem to be solved on time. So, so technologies, like if I started with stream processing maybe around 5-6 years back. So when I started, we had few options available, right? Storm was one of the leaders at the time. So obviously things have changed a lot. In the last 2 years, we have a lot more technology like Apex, and companies like DataTorrent are taking them and driving them forward. So next 2 years is going to be an exciting time. I am very excited to work in this domain, and this is a very good, very golden period I feel for the stream processing for the next few years. So if you look at the typical IoT data processing component, this is one view of looking at it, right? So you are going to start almost always with some sensor, right? The sensor is a very huge area to talk about. So you can have a sensor. We have example of sensors that is sitting in a water tank that sends the SMS once a day of what is the water level, or twice a day what is the level. You can have a sensor that is extremely, extremely expensive that actually tracks the, has 100 different, for example, one of the solutions we have is for monitoring planes. So obviously, you can think planes have a lot more sensors, and the use case there is where when the plane lands, if you think about the plane has something called minimum equipment list, which is once the plane lands, they are supposed to have MEL cleared. And based on the MEL clearance, the plane, the airline industry or the plane will be cleared for the next trip. So if you think along that line, the amount of data from that is a lot, right? So you're talking about thousands and thousands of sensors. Just an engine itself will have thousands and thousands of sensors. So you have this full spectrum of type of devices and sensors. So some devices, the example I talked about, the tape adapter, you have devices which slaps onto existing hardware, versus you have devices which actually you start from scratch, you design from scratch. So companies like the ARM processor technology, the Intel processor technology, they're all tuning towards that. It allows that platform to develop the device from yourself. So you have this huge spectrum of device sensors and sending data to the further the pipeline. So again, connecting devices, typically, again, most of these devices generally uses a Bluetooth or some of the Wi-Fi, and cellular is actually another area to, in our company, we have been focusing a lot on cellular, right? So each connectivity protocol, each connectivity system has its own pros and cons. So we have an example, one customer who has all the radio pretty much you can think of, right? So it has a Bluetooth radio to help the customer to log into their device through their phone. They have a cellular radio which will help them to send the data to the back end. They have a satellite. So for example, there's a trucking company where they go to get logs from remote places, it's unpaved roads, cellular coverage may not be there. So there actually they use satellite. So they fall back. So the connection technology depends on the problem you're solving and how much you can invest, right? So that is the next component there. So ingest multiple real-time streams of data. A lot of time people immediately map stream processing to that, right? That seems to be the natural fit for stream processing. But stream processing, in my opinion, spans across all of these. That's what you will see further down. That actually, whether it is a we have been in our company a long time, we've been using Storm, right? So now we have been migrating to newer stream processing technology for the ingestion. So ingestion actually can do other roles. Like for example, it may not be doing only the data transformation, cleanup, and lookups, and things like that. It may do merging of data. The example I mentioned earlier about the weather data, right? So you can take the tractor data and then merge it with the weather. Imagine somebody wants to actually, a person owning 10 tractors and a farmer actually wanting to lease a tractor, using the weather data and then proposing what is the appropriate time to do that step of the farming. So that you're typically using a weather data, merging it with the availability data, time series data coming from the tractor and merging that, right? So the role of the ingestion is a pivotal role, and particularly in this context, stream processing, it normally is a pivotal role. So obviously, the analyze, transform data into valuable information, that's another area where stream processing is going to play a role, right? So if you think about the first step, generally you are doing less, again, we'll see more about windowing function and things like that, but the concept of looking at data over a period, over temporal space, is going to be more on the analyze transformation data and less on the basic ingestion. The secure state storage and management of data, again, is probably less relevant in stream processing, but that becomes a bigger issue, right? Imagine you have a medical device, and the medical device actually has to go through privacy laws and HIPAA compliance. So a lot of when you're developing IoT solution, that is an area you have to think from scratch, right? It cannot be an afterthought. Application dashboard, interface, just like any other application. Some of the unique things that you have to think about from IoT context there is the response times, right? Typically, the stream processing are taking the information, responding within milliseconds many times, right? Which means your UI technology should be relevant for that. So you should not pick a UI technology which is slowing you down. So you have a context, the information ready to be visualized, a context information ready to be displayed. Your UI technology has to kind of go along with it. The revenue share business model splits. So again, in IoT context, so imagine that you have in a tractor context, right? So the revenue of somebody wants to use a connected vehicle to actually watch a video in the, or listen to a Pandora, right? Versus a connected car manufacturer wants to use the connected car to provide maintenance alert or to provide feedback to the driver from the quality of the vehicle. So you can think about that revenue and splits are along the line of how do you think about from business point of view splitting that investment into two different models where the Pandora can be paid by the driver, user, the owner of the car, whereas the OEM may pay for the sending the time series data about the quality of the car. That's an example of what do you mean by revenue. So stream processing in general is going to be applicable to all of that, and today at least I'm going to be mostly focusing on the first three aspects of it: the device, the connectivity aspect, and the kind of problem we are solving. That's the area of focus today. So the concept of stream processing, the way I think about stream processing is, I don't know how many of you guys actually are familiar with the 10 fingers game, right? So people are familiar with it. By raise of hand, have you guys played the game before? Okay, so it looks like I played it with my daughter. So this is actually obviously, typically teenagers play this a lot. This is a game where you have your 10 fingers up, and then questions will be asked. Never have I ever done something, right? So whoever not done that would actually have to fold one of the fingers. So the winner is going to be the person who basically, still survive with at least one finger or the most fingers, right? So the construct here is, if you think about the temporal aspect of that. So if girls of 13 years old playing that game, the time domain they're talking about is 13 years, right? If I join that without revealing my age, it's definitely going to be more than 13 for sure, right? So if you think about that, the construct of stream processing is along that line. It is unbound time, but obviously there is a bound to it within practical reason. So the concept of unbound is the kind of problem you're solving actually increases your time scale you're looking at the problem. So if you have read the O'Reilly blog here, if not, you should definitely try reading that. Here, this construct's all coming from that, right? You can read more about that later. Typically, the concept they're talking about is the what, when, where, and how, right? So the what has to do with any problem you're solving. You're typically asking a question, right? To answer the question, you have to do certain things. What is being done to answer the question? So example are, if you're calculating miles per gallon for a vehicle, right? Or you're calculating the turbine speed. So to calculate that, the device, something has to be calculated based on the pipeline we looked at earlier. So where it happens, that's a separate problem. But that is the first step. You have to know what is the algorithm. People translate to an algorithm. It may not be an algorithm. It could be as simple as I take a voltage of a fuel level value and then convert the voltage into liters or gallons. So the what is where most of the problem starts. So then the where in the event time results are calculated, right? So if I say that I'm going to update the counters as soon as I get a new event, versus I'm going to update the counters every hour, every day. So the concept of the question is answered using the windowing function, the different type of windowing function you have, right? So you have windowing functions like sliding windowing function, tumbling windowing function. So if you can, again, if you go read more about the blog, you have enough examples there. So the reason why I kind of go through the paradigm is because it translates to the different aspect of IoT. Different aspect of IoT, you need to kind of focus more on one of these idioms. So when in data processing results, again, this is the, so imagine that you are supposed to actually provide an hourly update. In every hour, you're looking at time series data or stream data flying by. And every hour, you're supposed to answer a question. So if you actually know that based on the context, the data is almost no later than a few seconds behind the reality, your SLAs and when you can commit to answering the question can be structured around that. But if you actually have a scenario where you can have the data coming in much later, you need to be ready to actually construct the SLA, construct the application around that. So that is the when aspect of it. The how aspect of it is, again, it depends on how the application is designed. You basically you're answering a question. Do you actually have to worry about retracting the answer and giving an updated answer? So that aspect is the how part. So at a higher level, these idioms of what, where, when, and how is something in any stream processing application you have to worry about. I'm just going to use the paradigm and apply it to the IoT context. So let's, again, we talked about different views of it, right? So the first view is of applying the idiom is through the device view. So the devices, like I mentioned earlier, there are different type of IoT devices, right? So the IoT devices, it can be a very simple device. It could just be these are typically driven as 20 to 25 cents each. So an example of that is you have a Bluetooth beacon, which actually, all the tiles and the application that you guys have used before, which actually is a Bluetooth beacon that whoever walks by, that beacon itself has no ability to communicate to the cloud by itself, right? So it relies on somebody to walk by and you piggybacks on their phone to send the information, whatever the information it has. So those are devices that are very, low cost. In our case, particularly, we work in many developing countries. So there, actually, the device that we are monitoring itself may be $20, right? So you can't slap on a $10 device on that. So these are examples where we use the low-cost device. So that the Crowd GPS is an example of that, where the tile, if you last year, I don't know how many of you have used the tile kind of application, right? So you have, okay, so a few people. So that is actually, you put on a Bluetooth beacon kind of product, sensor in your, whatever you're tracking. And then, as people walk by, if, for example, people put it on a bike, and then, if you don't know, somebody stole your bike, you can track that. Because somebody within the ecosystem walks by the bike, and it's able to piggyback on their phone because they're running the app in the phone to send the location of the bike. So you get an alert on that, and then you can do that, right? So that's what I mean by Crowd GPS, an example of that. The reason why it's Crowd GPS, because that device does not have a GPS radio. It relies on the GPS radio of the phone many times, right? Again, to keep the cost down. So here, actually, the what part, the example here is it doesn't even generate, it doesn't even know how to compute the lat long. It actually relies on the phone, and pretty much it's very limited in terms of other idioms, which means you have to worry about the idioms in a different context. This device is not going to help you there. But again, we also have to take that in the context of the building we are in, right? So if you look at the history of computation, if I have to make the same sentence maybe 5 years from now, these devices probably will be able to do more of it, right? So I'm talking about where we are. So the next is the typically off-the-shelf devices. These off-the-shelf devices are, it's very common to see all these GPS trackers. You can, typically in the connected vehicle space, we call them as OBD connectors, right? So these are devices that can connect to your vehicle through an OBD connector, or it could just use the vehicle as almost a battery source, right? So these are they have reasonable amount of computation. So some extent they can address the decent computation power is available. There's varying degrees. Some of them allow you to update a script, right? Some of them basically, you cannot update any script. You can configure the device, like frequency of how often it sends the data. You can configure that almost in all these type of devices. But if you want to actually do some edge processing, I don't know how many of you are familiar with the word edge processing or fog computing, right? Okay, few of them. So again, the edge processing or fog computing is very relevant for stream processing for IoT. So the way I think about that is edge processing or stream processing is an extension of stream processing for IoT. It's a matter of it helps you to minimize the cost. It helps you to achieve the SLAs to answer the questions, because it is a lot of time, a lot more cost effective to do stream processing in the edge than doing in the traditional or the newer technology coming along in the last 5-6 years. But it has a limitation, because if it's off the shelf, depending on the type of device you pick, it may not allow that. For example, we have solutions where we are putting this off-the-shelf device for a machine that itself is worth maybe $50,000, right? So where we can afford a $200 device. But we also have our solution running, tracking, devices that are $900, $800 devices, like motorcycles in developing countries. So there, you really cannot afford to go for a $200 device, if it's 1/4 of the cost of the stuff you are tracking. So there, we are using lower cost devices. So you have to be aware of this what, where, when idiom along these lines, right? So if you think about geofence example, so you can do geofence actually in the device. So you can send the construct around what you're looking for. How many of you are familiar with the word geofence? So Okay. So again, geofence is the idea of actually you have a device that is moving for whatever context it is. For example, mostly the vehicles and cars, generally geofence is applied. Geofence applies to us, right? So we have applications that actually families use to track their kids. I use that to not necessarily track my kid, at least I want to make sure my kid is on time in school, on time back in house. So that is geofence is about a location and time rule that you're setting up based on the sensor data coming from devices. You are able to get an alert saying that the rule is violated or not violated, right? So the geofence is an example of that. So the geofence example, you can think about in a complex devices like this allows a limited version of geofence. So if you want to have more complex geofence rules, these devices won't be able to do. That's where the what part comes in, right? So the second question is, say I have 5 devices located in 5 different locations. If I want to basically say, okay, all the 5 devices have to come together. A very simple example, take my daughter. Both my daughters have to come back to school between 3 and 3:30 in the afternoon, right? So there are 2 different devices, 2 different sensor data. How do you apply that rule? So that cannot be done by the devices themselves, right? It has to be done in the cloud or in the backend system. So that's an example of limitation of some of these what part of that in some of these devices in IoT. So I have 3 minutes left, so I'll try to rush. So the device view, again, if you think about the highly programmable device, here it allows you to do more of the windowing function, more of the when and the how part. Maybe the how part is limited. So I can basically do, it may have enough memory to store enough data over a longer period. So the connectivity, again, the fixed cellular versus cellular moving device versus highly reliable connection, right? So the differences between them two is, generally speaking, they are not going to be addressing your what and where. But the when and the how part, if it is moving devices, you really have to worry about the where and when and how part. Because the devices actually will go out of range if you're moving into whatever the connecting technology you're using. So when they go out of range, they're going to dump the data all in one shot. So that may be late arriving data, which means you have to worry about your where, when, and what. And how, right? So the what part, generally, the connectivity is going to be less relevant to that. So similarly, from a protocol view, again, if you think about the UDP versus TCP, the UDP, these are obviously at a higher level, the 2 protocol. I'm not going to the next level of protocol that sits on top of this, right? The MQTT kind of protocol which sits on top of this. So UDP, you have to worry about your where and when because things can come out of order. But unlike the cellular part, you're not going to be that hugely late arriving data, right? So people sometimes address that, find the balance because the UDP has a value of using because it reduces the cost of connectivity and the battery life goes up in general higher, right? So, but it comes up with a trade-off of you have to worry about the where and the when and the how. The people sometimes use the modified UDP, so the application level acknowledgement, that helps with your where and when to some extent. But that has a cost too, because acknowledgement adds your cellular cost. So that is the higher level summary. When you're looking at the IoT problems from a stream processing point of view, you should train yourself to look at these problems in terms of these 4 idioms. And whenever you're coming to SLAs and trade-offs, you always look at these through this angle. So I have a couple of minutes left. If there are any questions.
Hi, thanks for the presentation. Just curious how and if you are currently using Apex.
Yeah, so the Apex is something that we have started experiment recently. I don't have enough data point to say what is our experience so far. It is more of a recent experience for it. It's kind of too early for me to kind of conclude anything there, but it's more of a recent experience last month or so for us.
Okay, thank you.